As you see, I added the constraints, the main constraints to this linear programming so that these constraints must be converted to the crisp linear programming using lambda. As you see, there are three constraints. The first, the second, and the third constraint are greater than the right-hand side number. So we have two ways to complete this constraint according to the lambda for converting to the crisp constraint. You can save this inequality and into side of each constraint you can add the parameter lambda with coefficients and the allowable deviation. Allowable deviation is added to the right hand side and multiply lambda is added to the left hand side. But in situation of inequality or less than constraint, for greater than constraint, we must the expression on the left hand side, the expression is subtracted the lambda p. Okay, so I can add the negative negative 10 multiply lambda plus the expression is greater than the right hand side 170 minus the p2. For second constraint also we can subtract the 100 lambda from the expression and then minus 100. And for last constraint, you can add the negative 6 lambda minus 6. So now you have converted the fuzzy structure of linear programming to the crisp linear programming. After that converting, you can solve this model in commercial software similar to Lingo or GAMS. And other state of fuzzy linear programming. In the first state, we discuss about the structure of maximum or minimum, fuzzy maximum or minimum, and fuzzy inequality for constraint greater than and constraint less than. So in this section, we will discuss about the structure of this model. Maximum Z subjected to ax less than b, or minimum z equals c fuzzy x subjected to ax is greater than b. These are the standard format of linear programming, especially fuzzy linear programming. So, in the first place, some researchers proposed converting fuzzy coefficients or C to the crisp with averaging. For example, C is notated by C M C P C N and C O. CP in the maximum format denoted the pessimist value for coefficient, and Cm is probable value or moderate value, and Co denoted for optimist value, the best, the worst, the moderate or probable value. Okay. Some researchers proposed you can convert the fuzzy C to the C using the averaging these triangular fuzzy numbers. How you can for Cj obtain the C pessimist j plus 4 times C moderate j plus C optimist j divided by 6. Okay. Simply the quasi coefficient has been converted to the crisp coefficient. So this is this is not complicated for analyzing the fuzzy value. Okay, and we need to write the fuzzy model applying the membership function and membership degree. Some researchers proposed other technique for obtaining the crisp linear program. In other technique, they assume that there are the structure of TFN, triangular fuzzy number. Okay. This is C, and this is membership degree of C. C pessimist, C moderate, and C optimist. In this idea, they propose that you are going to maximize the objective function. So it is better to maximize the structure of this number. How we can maximize this number? If you maximize this objective function Cm multiply x, decision variables, okay? And maximize this interval. CO minus C moderate. Multiply decision variables. You are going to maximize the fuzzy model, the fuzzy objective function. And there is another notation that you must pay attention to this. What is this? This interval. And it is better, this interval, I mean Cm minus Cp is minimized. If you minimize the left part of triangular fuzzy number coefficient and maximize the moderate coefficient, multiply the vector of decision variables and maximize the right part of this number, you are going to maximize the fuzzy objective function. So this is necessary. You apply these objective function separately. Mean z1 equals C moderate minus C pessimist, multiply decision variables, maximize z2 equals C moderate, multiply decision variables, and maximize z3 equals C optimist minus C moderate, multiply decision variables. And these are subjected to ax less than b, for example. These vectors are now negative. Okay. This is assumed for maximum fuzzy objective function. For minimum, you must change the state of objective functions. For example, the first must be changed to the maximum, and the second must be changed to the minimum, and the third is changed to the minimum. Okay, so we explain the structure of converting the fuzzy linear programming to the crisp linear programming. There are three objective functions. In the first place, we are going to solve the model with individual objective function. Each objective function must be minimized or maximized according to their states. For example, in the first place, we must solve the minimum z1 subjected to this constraint. Minimum give us the best optimum solution and is called z lower. Okay, z lower for the first objective function. Uppercase is noted for the number of objective function. Okay, and once we solve the Z1 minimum, and once we solve Z1 for maximizing, and maximizing Z1 give us the optimal solution for maximum and is called Z upper. And for the second objective function, you have ZU for maximizing Z2 and ZL for minimizing Z2. Once maximize Z2 is modeled and solved in order to obtain Z upper, and once minimum Z2 is modeled and solved in order to obtain Z lower for second objective function. And for third objective function, you solve the maximum and minimum similar to the second. Z upper is obtained for after solving the maximum, and Z lower is obtained after solving the minimum Z3. And as you know, according to the formulation that I said in previous sessions, and we obtained the structure of converting the fuzzy linear programming to the crisp linear programming, especially for objective function. You can formulate these objectives according to Z upper and Z lower by considering the lambda or membership function. Okay. I say again the structure for Z1, Z2 and Z3. For example, for the Z1, membership function is like this: 1 Z upper minus Z. I can use Cm minus Cp instead of Z multiplied x divided by Z upper minus Z lower. Less than Z lower Z lower 1 and Z upper 1 and 0 for Z is greater than Z upper. This is for minimization, as you review and remember. Okay, for the equation, the inequality of crisp constraint, we must consider this membership population function is is greater than lambda. So we can rewrite this like this situation. Okay. Lambda multiply the upper minus the lower plus Cm minus Cp x is less than z upper. This is the inequality for first objective function. And for another objective function, for example z2 and z3, you can change this inequality on this part, on this term. The plus is changed to minus, and the z upper is changed to negative z lower. But this coefficient also is changed to the Cm. And for the third objective function, also this term, this coefficient is changed to the Co minus Cm, and the plus is changed to the minus, and the Z upper is changed to negative Z lower for third objective function. Okay, so we will have the new converted crisp model as you see. Maximum lambda subjective to the first inequality that we have written before a slide. Okay, lambda z upper z lower 1 plus C m minus C pessimist x is less than z upper 1. Lambda z upper 2 minus z lower 2 minus Cmx is less than negative z lower 2, and lambda multiply z upper 3 minus z lower 3 minus C optimist minus C moderate x is less than negative z lower 3. Considering some constraints, main constraints of the main model. And you can write this model on the commercial softwares like the GAMS and Lingo, and solve the model by running, and you then obtain the value of x decision variables, and lambda. These are the new variables. Okay. Other state that there is in the literature consider the right hand side number, and the technical coefficient in the constraints being fuzzy. And on the next session, I will discuss about the structure of this state, the fuzzy linear programming using B and A simultaneously. Maximum or minimum Z subjected to AX is less than B. I will discuss about this